As Steve mentioned, this is What's My Age Again, where we're going to take the Swift programming language, run it on the server. I know this was tagged accidentally as an Android talk for folks, so that's just a scheduling thing, no big deal. Don't worry, don't be afraid. There's not a lot that's specific to Swift. It's very basic Swift, so if you know any other modern programming language or you've accidentally bumped into a programmer at some point in your life, you'll be fine. So we're going to take server-side Swift. We're going to use it to communicate with IBM Watson's visual recognition API and query it for some interesting things. In this case, age, and even though it's not on the actual abstract, gender, because that ends up being some interesting topics to talk about with regards to bias in machine learning, which I'm glad to hear. It seems like a little bit of a theme at this particular conference, so definitely love that. And I don't think I'll end up having to need the entire time, so I do think we'll have some time for questions and answers, so please hold all your questions till the very end. A very common question I get is, do you work for IBM? No, Steve just said that I don't, so if you have questions about that and how I ended up choosing this particular set of technologies that we're using, come see me after the break if we don't run out of time, or just go ahead and ask me here during the Q&A session. So, a little bit about me, the explanatory page. In a past life, I was the iOS lead at OfferUp. You can think of it as a mobile Craigslist in the United States. Nowadays, I'm on the iOS engineering team at Simple, a fintech challenger bank type company. I think locally folks would know N26 and Monzo and Revolut. It's kind of like that if you're looking for an analogy. On the interwebs, I am known as @DevWithAHair, and it's pretty easy to find me on Twitter and GitHub and all sorts of different social and mobile sort of spaces. Also, all of the code and slides and everything, example responses, are already up there online, so if you wanted to follow along, please do. Okay, so here is the agenda. First, we're going to talk a little bit about IBM Cloud Functions and what that means for what we're using it for. Also, we're going to talk about Watson's visual recognition API. The next part will be discussion of like what kind of microservice are we going to create in Swift. And then the big bulk part of the talk is actual like hands-on coding, not like Neil's yesterday where he was like live coding it, but it's pretty live, so we'll see. Okay. So IBM Cloud Functions are an example of what is called the serverless architecture. You've probably heard this buzzword. And despite its very confusing name, there actually are servers involved. It's kind of like NoSQL, where it had a really, clickbaity sort of brand name to get people excited about it, but it actually does involve servers. The big difference with serverless is that unlike, say, like an Amazon EC2 instance, that you go, you stand up the virtual server, and it sits there and it twiddles its thumbs, hoping that someday, somehow, somebody it believes will eventually request something of it, and it'll process something and then go back to sitting around waiting, twiddling its thumbs, waiting for somebody to do something again. And you're getting billed and charged the entire time. And also when things like Spectre come out, it's like, whoops, all of your servers are completely unpatched, now they have to be shut down, repatched, and restarted. With serverless, the big idea is that your server doesn't exist until the precise moment in time at which it needs to exist, when a request comes in. And critically, it only exists long enough to process that request, give the response, and then it goes away. So if there's any Rick and Morty fans in the audience, this is a lot like the character of Mr. Meeseeks. For those of you who haven't seen the show, there's a fancy little magic box. You press a button, and a little character comes out and says, "Hi, I'm Mr. Meeseeks. What would you like me to do?" It completes the task, and then instantaneously stops existing. That is the whole life cycle of a Mr. Meeseeks. It only exists long enough to do something useful, and then it ceases to exist. That's what serverless is about, and that's a lot of how IBM Cloud Functions happen to work. Folks who might know, like Azure has a very similar cloud function, Google has a very similar one, and I think a lot of folks know AWS Lambda, where You write what is basically just a very simple function, and it runs when it's needed, and then it stops running once it's finished processing. So that'll make it really easy here for us to show an easy example of like, let's get a request, let's process it through Watson, and then let's give a response. And speaking of Watson, for those of you who may or may not remember, the Watson branding was pretty popular around the time that IBM came out with the Watson computer that competed against, at the time, human champion Ken Jennings, who had won like 70-some episodes in a row or some absurd number. And it defeated him pretty handily, right? So that was like, oh wow, like look what AI can do, look at the power of this. Branding aside, that's sort of what we're going to end up using with the Watson Visual Recognition API. It's an example of deep learning. It lets you do both halves of machine learning. It has the classification side, so if you really, really desperately wanted to create the Silicon Valley hot dog or not app, you could get a large corpus of image data for hot dogs and things that are not hot dogs, train the network, and then run your app. In this particular example, we're just going to go ahead and use the inference side, and that's basically a fancy word to say we're going to use a pre-trained network. In this case, the network that the folks at IBM have gone ahead and trained for us. All right, so let's talk about this microservice in Swift that we're going to make. It's pretty basic. We're going to take in a request in JSON format. In this particular case, it's going to be the image URL reference for the image of the celebrity or myself or anything else that we want to analyze. Then our function is going to call out to Watson using their Swift SDK, so that's pretty handy, nice little wrapper. And then we're going to process the response and send it back out to the world in JSON format. All right, let's get to the coding piece here. Oh, and oh, by the way, for those of you following along at home, this is where the resources are on GitHub, Dev of the Hair, conference talks, and this conference talk is What's My Age Again? All right, here we go. So what we're looking at here is a really nifty visual editor that IBM provides. You can use things like Xcode and program locally, but for the purposes of this demo and for the purposes of like getting started really easily without having to set up an entire tool chain, once you create an IBM Cloud developer account, you can just go ahead and come right into their little editor. So let's go line by line. First thing you're going to want to do is to import dispatch. I will explain this in about 2 minutes, so don't worry. Just remember that. Second thing you're going to want is to import Visual Recognition v3. This is the very weirdo name for the Watson Visual Recognition API in the Swift SDK. So this is exactly what we need here to get to. Here, at the beginning, I said, wow, we're going to develop a function. And guess what? It's pretty much just a normal method here. You have your main piece that takes in, I said at the beginning it was JSON. It's technically not JSON as far as your function is concerned. The cloud infrastructure manages all the serialization and deserialization for you. So technically, you're seeing a dictionary here that maps a string to any, and then you're going to return a, again, fake JSON in this case, of string to any. Next line here is our container for just a little temporary variable for our response. We're going to return a dictionary. Just think of it as JSON under the covers if that's what you want. These next few lines, especially for those who aren't super familiar with Swift, this is a guard statement. It's a really handy way to say, all right, I need to make sure my preconditions are true, otherwise I can't do any sort of processing. And what this is saying here is, if I don't have that image URL within that JSON request, I'm sorry, I really can't do anything. I'd love to help you, but we're just going to return a response of like error, missing image URL. So please try again. I'm so sorry. The next piece here is probably the piece that I get the most sort of sideways glances from other iOS developers. This is a dispatch semaphore. And it doesn't really matter too much what it is. If you think of it as being like a traffic stoplight, it's a pretty good analogy to use where in a real-world stoplight, when the stoplight is red, traffic stops. When it's green, traffic goes. And the reason we care about that here is that these cloud functions want to run from just top to bottom in your code. So it's a little bit different than an app. An app usually has a main thread that is just sitting there spinning, waiting for activity from the user to do something. So it stays forever. But this right here is by far the best pro tip from this talk if you're trying to get to do this sort of thing. The Watson SDK is asynchronous in nature. So if you're like me and trying to debug this and you're wondering, why is it just sitting there spinning and not doing anything? Well, what happened was your code ran from top to bottom. You called the Watson SDK. It got to the bottom and said, response is good, kill this thing. And you never got your code back until like 5 minutes later, the whole activity times out and you're left wondering what in the world happened. This stoplight would be important where we're going to say, all right, after we set up all of our code, we make the call, we say, hold on a minute, stop the cloud function processing while we're waiting for the asynchronous response to come back, and then we'll set the traffic light back to green and let things continue and return the response. And speaking of responses, things can always go bad. Even if people have sent us a proper image URL, there could still be other areas that are going to fail. It always happens, particularly in live demos. So if there is a failure here, the SDK takes a failure closure, and in this case, because this is distinctly not production code, I'm being very lazy here and just saying, we're going to give you a response of error and then just give us a string version of whatever that error happens to be. All right, next piece here. You're going to need an API key. And for those of you following along at home, you might be wondering, why are these lines of code different than what's on GitHub? Well, the reason is I knew these sessions were going to be recorded. And as much as I love you all, this is my API key and not your API key. Please go get your own. So all I've done here as a change from what's on GitHub is just take some runtime arguments so that it's very carefully hidden away from your eager but prying eyes. Okay, this next part, API versioning, is a little odd in Watson. It's not a typical API version where you say, oh, this is 1.x, or you know what, we're using 3.5.2. No, instead, this uses a date-based API versioning system, which completely blows my mind. And for a very long time, they would recommend in their documentation that, oh, what you need to use is just use today's current date if you want to get the latest and greatest code. For reasons that I'm sure are quite obvious to you out there, they decided maybe that wasn't the best sort of idea, and have actually changed it to be a specific date. And in the latest documentation, that date is March 19th, 2018. And as you might notice, they last updated that March 21st, 2019. So word to the wise, make sure your API date matches up with the official release notes and documentation for Watson. Next line is very simple. All we're doing is instantiating our visual recognition object from the SDK, passing it in the versioning and the API key. And then here's going to be the real meat here. We're going to tell the visual recognition, hey, we would absolutely love it if you could detect some faces from the image URL that we had before. Use this failure closure if something should go awry. But at the very tail end here, for those who are not familiar with the syntax, this is a fancy pants way in Swift to say, hey, we have this trailing closure that if there's a success, go ahead and start running this closure. And in this case, we're going to have this all images thing that comes through. And a lot of our processing here is going to be related to dealing with this very odd data structure that's kind of like a Russian nesting doll. You have, I think, detected faces at the outer area, which can have 0 or more images associated with it, and each one of those images can have 0 or more faces, and then a face may or may not have an age, and a face may or may not have a gender. So a lot of this processing, if it looks scary to you, it's really just trying to unravel a whole bunch of that data structure. So first, we're going to have our face results, because we may or may not have 0, 1, more, 2, n number of faces. So we're going to return that as like an array of dictionaries, or a dictionary is sort of set with each individual piece of the response collated together. So for every image in all of our images.images property, and for every face in our image.faces property, we're going to have an individual face result, so temporary storage here. And then we've got this unwieldy line here, which in Swift is just saying, okay, make sure that I have an age on that face, make sure I have a age minimum, an age maximum, and this wonderful thing called age.score that we're renaming to confidence and age, and that's really just saying, okay, we gave you this range from minimum to maximum, and here is a confidence score. It's a floating point between 0 and 1, roughly mapping to the idea of the percentage confidence in how confident is Watson that it didn't make an error in this case. So that's what we're going to do here. We're going to create our little response structure here of a minimum age, maximum age, and confidence. Append that to our face results. And then, then we're going to do the same thing for gender. Now, gender is an interesting one here because they also give a confidence score, which is interesting. But the gender, I think to IBM's credit, they didn't choose a Boolean. They didn't choose an enum. It's actually a type of a string. I think that's pretty fascinating. That I hope the reason they did it is a recognition of the fact that gender is non-binary. So a simple thing like a Boolean or an enumeration is not going to give you all the diversity and inclusion you would want to have to cover the whole like rainbow of people. So kudos to them if that's what they did. If they didn't, well, they gave themselves a really flexible data structure. So just like we did above, we're going to take gender, we're going to take confidence, add that to our face result, append the individual face result to the array of face results we want. Same thing for the response. And remember the traffic light, the dispatch semaphore, right? So at the very tail end of all of our code, we're going to tell things, hey, traffic light is red, please wait, make the call to Watson, and then within what we were doing before, we're going to say traffic light is green, go ahead and continue, and finally return that response and comment that. So let me save this. That's uploading the latest and greatest to Ibm Cloud Functions. And let's start testing this out. This is the fun part. Okay, so remember what we said? We're good test-driven developers. We didn't actually do it here. This is test-back development. But we want to try out, like, what happens if a user provides us with incorrect JSON? They didn't have the image URL. All right, well, let me apply that. Invoke here. And we see, hey, our code works. Error, missing image URL. Fantastic. But now let's do the actual fun part. So here is our first celebrity. This is the first of many really bad speaker jokes I'm going to make. That is Taylor Swift, and I am writing serverless Swift here. All right, so now that I've amazed you with my comedy, image URL. Let's give Miss Taylor Swift. Let's invoke that. All right, so we have our results. We have an age ranging between 20 and 23. When you average that out, that's 21 and a half, and by Banker's rules, that is 22. So that's the last of the speaker jokes I'm going to be making. The confidence here is pretty high, right? I don't know what Taylor Swift's age was at the time that photo was taken, but reasonably close to 22. And the confidence here is pretty high. This is roughly 89%. So we're doing good. We're doing brilliant. And as far as gender goes, it's many nines confident. Like, you would really want your cloud provider to give you this many nines of confidence. 99.99995% sure that this gender is female for Taylor Swift. So that's good. Next one we want to try. This is not a speaker joke, but just an acknowledgement that Swift is an Apple technology, and Mr. Steve Jobs here is a big name, or was a big name in Apple's ecosystem land. Let's see if it gets that correct. So let me give you the new URL. Invoke there. All right. Age, pretty good. Steve Jobs was around 57-ish probably when this photo is taken, so 55 to 58, that's pretty solid. 97% certain, we're looking good. Gender is also pretty good. Identifies male, 98%. Everything's looking brilliant. We're ready to ship this code to production, right? Oh, that's a leading question. So this is me, in case you couldn't tell. Granted, this photo was taken a handful of years ago. I want to say it was at Ennis North, at Le Chateau Montebello. So probably 3 to 4 years younger in this photo. Audience participation. And I'm not going to be offended. I really don't care what number you choose. Just please choose a realistic one that you actually legitimately think, not a random number. And what are the ages that people think? How old am I right now? 35, that's one. 32, that's another. 33, is that what I heard? Okay, okay. Let's see what Watson thinks. Have you tested it with a hair comb? I haven't. That's homework for the reader. And so we'll take some photos out in the hallway and we'll try that out. We'll muss up my hair. All right, let's try this. So while this runs, my actual age right now is 37, so pretty good for a lot of the guesses out there. Watson thinks a little differently. It's about a coin flip sure, about 53%, not very good confidence. It thinks I could be, between the ages of 26 and 21. I would absolutely love to be 21 again, trust me. But I'm not, so it's fail there. And to its credit, at least it got the fact, yes, I am a male, identify as male, 90% accurate. Right? It's like, well, I'm not sure. But the age thing is interesting. Like, there's a very particular reason why I keep this mustache, and that's so I don't appear like I'm 13. I look a lot younger to a lot of folks. I get carded at the pubs and the bars all the time. I'm just used to it. But it's the first example here, right? That even something that we would think is so easy, like age, little questionable here when you're using this sort of technology. It failed here in this spot. So let's give it something more challenging. All right. Ponder here for a moment. If you don't know who this is Tig Notaro. She's a brilliant comedian. She's got a great Netflix special that came out probably around this time last year. And in that Netflix special, she says, you know what? On a regular basis, every week I'm out in society. Every week, somebody somewhere thinks that I'm a man. And she's not. Tig Notaro is a woman. Let's see what Watson thinks. Let's see what it thinks. All right, so age is actually pretty good. I mean, it's not very confident, but I think Tig Notaro is around 48, 49, so 47 and 51, pretty reasonable. But what do we have here? 78% confident, that's still, you'll graduate with a 78 average. That's nothing to be ashamed of. But it says male. And Tig Notaro is distinctly not a man. So what happened here? I don't know. I don't work at IBM. I'm not in their engineering team. Machine learning is not my background. But if I were to guess at the kind of data they have, I look there and I say, well, they probably have a lot of data that says males have short hair. I don't believe that's true, but I could see why they might have had that data set. Also, males tend to wear this sort of outfit that it's a suit with shoulder pads. All right, and to be fair, this is an off angle, right? She's a little bit more off to the side, sort of look. But it's kind of terrible that, how would you feel if it got this wrong for you, right? I mean, what does that say about our diversity of people who are working in this sort of projects, of people who are providing data sets, how certain can we be about a lot of things that machine learning might do? And that's not to say that it's a bad thing. I don't think that I think it's a brilliant technology. I also think it's the sort of thing that we need to be sort of careful about, right? Like if you can't handle something simple like age and gender identification, how can you really be certain about, well, I absolutely did identify you, you are the guilty party? Or even worse, deciding like, well, what can we do? Can we use this technology to decide penitentiary, prison times? Like, well, I kind of rather you didn't for that very reason, right? It's not to say it's a bad technology. I view machine learning as being something a lot like a lot of other technologies. Fire is a technology. Fire is dangerous. People die when it's misused. When properly applied, we have wonderful cookouts. We enjoy tasty food. We warm up the water in the dormitories. So it's a brilliant thing, but there is a responsibility to it. So I hope if you take anything away from this talk, it's not that things are bad or things are good. There's a lot of cool, nifty things you can do. The code is online. You can go play with it yourself and try things out. Please don't put it in production. Please don't use it to determine any sort of like horrible consequence type things. It's all in good fun. And as I flip things back, as I said, this is probably the slide. If you're going to take a photo of, that's the one you want. That's where my talks are. We'll have the speaker slides up on Slack. As I said, my name is Jaime Lopez. I'm at Dev with a Hair. And thank you very much. Go back for those of you. Do we have any questions in the audience? Sorry, it's like the fury of 1,000 suns facing me here. I can't see you.
Hi, thanks for awesome speech. And I would like to ask you, did you try to compare IBM Watson facial recognition with other APIs for facial recognition?
I haven't done any sort of like benchmarking. I ended up, to sort of give you like, here's how the sausage is made in the factory. The reason I ended up choosing this particular one over equivalent functions in Microsoft Azure, Google Cloud, and Amazon Web Services recognition with a K, like Mortal Kombat, is at the time that I wrote this, IBM was the only one who provided the native Swift support in Cloud Functions. You always could do the Node.js trick, because every Cloud Function provider does Node.js, and you can exec out to a binary. It didn't feel great, felt kind of hacky. And I also wanted something that would be pretty easy. If you go to GitHub, you can copy and paste, get things into your own cloud editor on IBM, and get started pretty easily. And again, I wasn't trying to benchmark these to compare those. So I don't know how that would work, but I can kind of guess that you would end up with maybe some similar problems. Does anybody remember when Microsoft's Garage team came out with the "How old are you?" website, where you could upload your own photo? There was a lot of very disappointed people who also got their ages wrong. It's like, what, 42? There's no way, I'm 21. It's like, well, maybe you don't hit the pub too often, you might feel a little better, right? And then, they had like other things that have gone wrong. Amazon, I think, fairly recently had this technology it's tried to use machine learning to run it on this whole corpus of interview candidates we've had and people we've hired, and try to feel like, can we just automatically determine who a good employee is? And you know what that technology did? It started to hate women. It said, from Amazon's hiring practices, if you're a woman, like, just don't hire them. Like, apparently, based on this corpus of data we have. And that's the thing, right? Like, that's the huge thing. So I can't speak for, like, the other part of the West, but within the United States, cloud technology providers and technology companies like Facebook and Google, Microsoft, Amazon, and so forth, they're really good at this sort of face recognition if you are a young, light-skinned male. And not so good, even within our own country, if you're a older, dark-skinned female, right? That's just the fact of life. And it's kind of interesting to hear people in the technology space in the USA say, oh, well, Asian faces are just difficult. It's like, are they really? Like Baidu in China is doing the same thing, and they're brilliant at doing Chinese face. I wonder why that is. Is it because of their own background and their own teams adding, oh, this is the official corpus of data we're going to use to train this system, right? That's kind of the meta point from this presentation. But thank you for asking that.
Thank you very much.
Any other questions? Perfect. In that case, thank you very much, Jaime.
All right.